All right, good morning, everybody. Thanks for joining in on the March webinar. Just give a little heads up to everybody. Last time, January as well, I was in the warehouse on our demo mic review here, conducting the webinar. So if you hear a couple doorbell rings as shipping comes in, I apologize about any background noise for you. But yeah, again, thanks for joining in. We're doing these webinars about every other month, just to kind of help you guys out as programmers and techs trying to get better at the MicroView Inspect software. Anything that we can do to help you guys out to program more efficiently and better. That's what we're here for. So my name is Dustin Smith, and in the chat you'll see Dan. We're both application techs, training techs, and inspection techs here at ATI. So anything you guys need for MicroView support, any other measurement support, any third-party inspection projects, if your team can't handle quantity, or if your customer or supplier is requiring a third-party inspection, we're here for you. So always feel free to reach out. You can email training or metrology or inspection at atiquality.com to get a hold of our team here. So first thing I want to talk about, get some business out of the way. We are hosting a metrology training seminar in Milwaukee, Wisconsin. 3 days. Every day is designed a little bit differently, so you can attend one day, all 3 days, or 2 days. Day one, we're doing a Blueprint 101 class, perfect for new technicians that aren't too familiar with reading blueprints and knowing all the different lines and symbols and everything that we get to look at all day. Day two is MicroView Basic and Advanced training. I imagine a lot of you on this webinar today have gone through our Basic and Advanced class. So that's day two. And then day three is a new class that we are running. It's MicroView GD&T, where we go into every single GD&T dimension, how to measure it on the MicroView, best practices, and ways to get those results for you. We have discounts for 3-day registrations, 2-day, and if multiple people on your team. So a few seats left as registrations are coming in. Feel free to email Dustin at atiquality.com or training at atiquality.com, and we can get you a formal quote and tell you more information about that. Back in January, we had a Tips and Tricks 2.0. Back in April 2020, or I believe it was late March, we hosted our first free webinar. As everything was kind of shutting down and people were working from home, we figured we want to still get you guys the quality training that you guys deserve. So that was 1.0. January was 2.0. We went over some basic, intermediate, and advanced programming tips, order of setting up systems, some datum tricks, some focus point tricks, and flipping working planes. We're going to talk a little bit more about flipping working planes today. But I do record all these webinars, so if you missed any in the past year, feel free to email me, and we can talk about getting you those recordings. So in January, the basic level tip that we talked about was all the F keys. When you go through MicroView training, we talk about hitting F2, you can rename features, F3, tolerancing your features, and F4, exporting your features. There's a few more in there that you're able to use to program faster if you like using hotkeys. F5, if you are measuring a circle with more inputs and you're using, say, 6 F-scan arcs around that diameter, and then you want to go to a new diameter, instead of having to go click circle in the features tools, you can hit F5 and it starts a new same type feature on there. F8 moves your machine to load position. So make sure everything's off your stage. If you've never done this before, hit F8 and you'll see, if you have a vertex, you'll see the stage go to the front right corner. If you have an Excel machine, you'll see the camera go up and go to the back of the stage there. So I like putting these F8 at the end of my program and then putting a move through point at the program. So at the end of your program, the camera or the stage moves out of the way so you can load the parts off and load the parts on with ease on there. And then F9, if you have a rotary attachment on your MicroView, this actually disables or enables the rotary. I wanted to bring this up because a few customers have had a rotary and they go to run a program and the rotary doesn't move. Probably from somebody typing in a number or something like that, accidentally hitting F9, and it disables the rotary. So it's a little trick there. Intermediate tip, we talked about flipping your part halfway through the program. We have a lot of times that we'll see two programs for the same part because you have to flip the part halfway through to get a different view on it. If you use the prompt button and put a prompt in there that says, you know, put your fixture, flip the part, whatever the directions you may need, this actually stops your program in its tracks. And when you hit OK on that prompt, it continues the program. So it's a little trick to stop your program halfway through, do some things that you need to do, and then let the program move from there. And then the last advanced tip we talked about was using the translate and the grid. So you see my little circuit board here with all the diameters, and on my blueprint I had all the basic dimensions on there. So I was able to just measure one diameter, set the origin, and plug in all my basics from there, and it actually goes and measures all those diameters by itself. The machine runs there. And side topic, as I'm looking at my screen, I've had some suggestions from you guys, which I really appreciate, to make my mouse larger and have a trail on there so you guys can see where I'm at. And I realized that on my WebEx that I'm looking at on my phone, it doesn't show the different color large mouse thing, but I'm going to try my best to hit control so you guys can see this highlight feature on there. So I apologize about that. If you guys know any other softwares that we can plug into my computer to give the highlight, I would love that feedback from you guys. All right, so March webinar tips. We're going to talk about basic, intermediate, and advanced programming tips. I'm going to try to do this every webinar of giving a simple, an intermediate, and an advanced programming tip to help you guys along the way, so all skill levels are getting covered. We're going to talk about some different things about measuring flash and burrs on your parts. It's a big topic that I see more and more on blueprints that, you know, it's always been on blueprints, but more and more are regulating it and actually having to report these things. So I want to show you some tips on there. We might get to storing systems and features on here. We're going to talk about chamfers, running multiple parts possibly, and a few other things. And I want to show you at the very end of today's webinar a program that I was at a customer helping them dissect their program, seeing if it was the best way to run it, if they're setting up their systems correctly. And we learned some really cool things about flipping the working plane and rotating the datum. So a couple tricks there that I want to show you guys, pass along as Dan and myself are at customers, you guys, helping you guys out with programs and training. We even learn things about the software to really push the capabilities of the MicroView systems. So as much as we can share to you guys to help you guys program better, that's the goal here. So let's keep going here. Let's talk about the basic level tip. The basic level tips that I'm going to always give in these webinars might seem very, very, very basic, but sometimes they're very helpful. This month, I wanted to talk about which way do we put the red arrows when we are scanning an edge, when we're taking a diameter. Do you go dark to light? Do you do light to dark? Does it really matter? And how many of you didn't even notice the red arrows? Just put them there as a little joke. So I'm going to switch over to my inspect software here. So I got this little, it's like a headlight plug here. And if I came over to scan this edge right here, and I do a line and I do an F-scan line, you can see the red arrow is right here on the left. So with that F-scan tool, it's looking in that dash line box for the edge close to the center of that tool. And that red arrow is the scanning direction, looking for that contrast. I've said this a million times on these webinars, you need the best contrast on the part with your lighting to be able to get solid, repeatable, accurate lines and edges on there. Back, I believe it was maybe October, I did an hour-long lighting webinar. So if you guys missed that, let me know, because a lot of lighting tricks for highly reflective parts and clear parts there. So here, the easiest way that I describe which way to do the red arrow is whichever direction has less noise. When I mean noise, it's that gray value. Like I said, we need the best contrast between light and dark to be able to get those edges on there. So my part's white and has some, you know, reflective parts to it, and could be gray, especially if you guys are dealing with any metal parts. You're going to see a lot of gray values on the top of your surfaces. And so that's what I mean by noise, is that there's a lot of gray value. So in this case, we don't even have light and dark. We have some shadowy gray over here and then some white on the part here. So the arrow is scanning in this direction and sees less noise in the shadowy part over here. Now, if I turned on my profile light and I come down over to this part here, in reality, there is no noise between the light and the dark here. So that's something where, honestly, it really doesn't matter. But where you want to take a look at is if I do a line, F-scan line down here, take a look at your points view. See what your points view looks like. If I flip it over, so it's going light to dark, it really doesn't change the points view at all. But if you notice a difference between which way the F-scan or line or circle is measuring, look at your points view and see where you get more consistent points along that best fit line or circle that you're looking at. So just a little beginner tip there. Let's jump back to here. Intermediate level tip that I was planning on talking about today was planning your magnification. When I start to do an inspection project, I like to battle plan before even getting on the microview. And I've talked before about highlighting your GD&T, highlighting your datums. If you guys have a touch probe attachment, highlighting what you're going to get in vision first, and then highlighting what you're going to get with a touch probe so your program runs faster. You do all your vision first, and then you jump over to your touch probe so you're not going back and forth between camera and touch probe and wasting that time. Planning your magnification changes, if you know you're going to have to go, a higher magnification in certain features, get all of those measurements in one time. Each magnification change in your program roughly takes 2.5 to 5 seconds each. And one thing that I've learned is the average program changes magnification 10 times. So that could equal up to 83 minutes if you run 100 parts. And we're all in the business of manufacturing, and we know that time is money. So the faster that you can measure parts, the faster you can get reports out and get them shipped, finish your PPAPs and your FAIs, all that kind of thing. So I got 2 programs here that I want to show you. I want to show you one that's jumping magnifications throughout the program, and then one that I plan the magnifications. So here we got this part here. I made it fully automated. I'm going to go ahead and run it. So there I'm at 1 magnification. I come down, take my Z hit here, and then I come up, and then I switch down to a higher magnification for this radius. Then I go back up to a lower magnification for the line. I go back down, and it goes like that around the part. Because I have given you guys tips before of when you're measuring your part, you don't necessarily have to go in order of your blueprint numbers. Go clockwise or counterclockwise, whichever way you want to go around the part, to be able to program faster instead of jumping all over the part. Now this program here, I timed it earlier. It took about 35 seconds to run this part. Now, if I come over to my planned different magnifications and I run same program, same features, 17 features here, but I planned my magnification so I wasn't jumping all over the place on here. So I did my lines at a low mag first, then I did one magnification change and did my radiuses here. I timed this one and it came in at about 19 seconds there. So that was a 15.5 second difference between the same exact features, same exact magnifications for those features, but I planned my magnifications through there. So I'll go to your local Office Max or Staples and get yourself as many highlighter colors as you can and get used to highlighting your GD&T, highlighting your different vision, but then also highlighting them in your different magnification, so you can battle plan your inspection processes or projects before you even put the parts on the machine. Because that 15 seconds per part, you guys can do the math, will add up over your inspection. And I know I see a couple names on our participants list here that we did a long project with last year, and they sometimes have to measure 200 parts per lot. And so when you're measuring that many parts and multiple lots, you got to save as much time as possible on there. So I'm sure you guys can relate in some way there. Now, if you guys have programs that you already wrote and you realize that you can change it up to make them run faster, we'd love to help you modify your existing programs. Give us an email and we can start that talk and see how we can help you guys make your programs that are already written faster. All right, advanced level tip. I want to talk about measuring cones with vision and letting the machine do the most of the work for you. I believe I'm planning on what would be March, April, May, the May webinar. I want to talk about measuring 3D features that are difficult with just vision, but then also showing off some of the touch probe capabilities. If you guys don't have touch probe on your machine, it's real nice that the MicroView is already set up. It's the same software, so you don't have to buy any new software. It's just a touch probe attachment. But also I know a lot of you won't get a touch probe because of stage size space, or I shouldn't say won't, can't get a touch probe because of magnification levels. But so I want to be able to make sure that all of you know that you can measure full 3D features with just vision on there. So measuring a cone with vision, not this type of cone, this type of cone. I told myself I wouldn't laugh at my own joke on there, and I hope some of you guys are laughing on that. But I was trying to find a blueprint for an ice cream cone here. So let's measure a cone here with letting the machine do most of the work for you using the rotate feature. And that's why I made it an advanced level tip, is because if you're just getting new to the machine, you're unfamiliar with rotating features and that kind of thing, I want to make sure that we covered that here. I just got to find my cone. Here we go. Cool. So a really reflective part here. I'm going to adjust my lighting. Sidebar lighting tip. A lot of the times I'll forget to check the axial light to see how axial looks. So if I want to get this diameter here, when I was talking about a lot of the noise that we have going on, this is what I mean, is I have a lot of gray value here inside the cone. And then on top, that machine surface, we've got a lot of noise going on, that there's a lot of contrast, or not a lot of contrast, there's a lot of gray value going on. So let's check out lighting a little bit before we even get into this cone. And I cheated, and when I was, planning this webinar, I knew axial light was going to be really good. And look at that contrast. And like I was talking about in the beginner level tip, is which way I want the arrows to go. This time I want the arrows to go dark to light, because there's less noise in the arrow direction of the arrows there. So measuring this cone, first thing I'm going to do is I'm going to do a circle. Let me do file new first. So I'm going to do a circle. I'm going to go ahead and use best edge, or I could use F-scan arc. Let's use F-scan arc so we could show you the arrows. Move here. And so you guys can see in my points view how scattered those points are, because it's picking up a lot of that noise that is on the surface of it. And if you guys can see on your screens, there's a little white crosshair on those blue points. And you can see where those points are actually hitting on the surface. So I'm gonna flip over, and now you can see my points view. There's some chunks taken out of this. This is a really old demo block that I have. But it's a lot cleaner edge that I took around there. So just flipping my arrows gained me more repeatability and accuracy of the real shape of this diameter here. So anytime we're going to use the rotate feature, we need to rotate about a system. And even if this diameter isn't my datum structure, you can set multiple systems throughout your program to help you out. So say the system was the corner of the part, I can put my system, so I'll set my origin to this diameter, and then I'll do the rotate feature here in a minute, and then I could click system and go back and copy my original datum structure system. So I'm able to change systems throughout the program, but for rotating any feature, we need to rotate about a system. So when I rotate, I want to rotate about this system that I just set to the center of this diameter here. So now let's get to measuring this cone. I always like to recommend anytime we're rotating features, or even if you're measuring a diameter that's using different lighting, like if I was going to use this specific lighting, I like to start at my diameter at about 12 o'clock, just so it's easier for me to place the points, know where I'm at, but also this lighting, when I rotate, it's going to rotate the lighting with it as well. And so you're helping the machine out. Instead of being at a weird angle, you're at 12 o'clock here. So anything that we do in Z, remember, we want to be at a higher magnification. You gain accuracy in Z at a higher magnification. So I'm going to click cone down here in the features list. Trying to use that control button to highlight where I'm going. So I'm going to click cone. I'm going to click more inputs, and I'm going to use the focus point tool here. So one thing to keep in mind, anytime that you're at a high mag and you're going to use focus point, get where the middle of the crosshairs is going to be in focus as much as your eyes can see, because remember, when you hit the focus point, it's going to autofocus, and you don't want to bump into the part if you're out of focus here. So I'm going to place 1 point. And then down here in my inputs, I just have 1 focus point. I'm going to right click on that focus point, and I'm going to rotate. And I'm going to say 90 degrees. And I want 3 copies because I have 1 point, and it's going to take 3 more copies of it to get to 360. So I got that. I don't have a cone yet because 4 points doesn't create a cone. Now I'm going to come lower down into the cone and take another point. And notice in my inputs, I have the 4 points here. So it's going to take those 4 points first. And I'm going to take that, and then I'm going to rotate that 5th point. Same thing. I'm going to say 90, 3 copies. And now I can right click on that cone and remeasure. You can see as it goes around, it changes the lighting that I have to that angle. So with the click of a couple buttons and rotate, I know that I have 4 points at 2 different heights, exactly 90 degrees around each other from that center of that diameter, and I got a cone here. You can see your included angle. So you can do as many points as you want. One thing that I like doing actually is I like setting the lower diameter points at 45 from the original point I took. So then I know I'm getting the real true shape of that cone on there. So you can see that even though it's just a camera, it's not, not using Touch Probe or anything, we're getting some real 3D measurements in there. So in May's webinar, I would love some real life examples from all you guys of what your challenges are of measuring cylinders, spheres, even cones, those real 3D features that you're having some difficulty with. And if I'm able to use your parts real life examples in the webinar, that'd be fantastic. I understand sometimes you can't release parts to the public and stuff like that, but I would love that. And so when I send out the survey after this webinar, if you have any examples that you would like to see live on the webinar, I would really appreciate you responding back on that one. So yeah, that was a quick little measuring cones there. And this little just for fun tip, I've had a couple instances where I want to rename features the same thing, but MicroView doesn't let you rename them the same thing. So when we get to the example program that I want to show you later, we flip the working plane about 6 or 7 times. And I want to keep track of what my system XY is and what my system YZ or XZ is, but I can't rename all of them the same thing. But just a little fun tip is that if I wanted to rename this, hitting F2, name this Dusty, and then if I wanted to name this system Dusty, you notice the OK mark goes away. You can't hit it. But if you just simply hit the space bar, MicroView Inspect sees that as another character. So now they're named the same thing visually, so your program can look really nice and clean with multiple systems. So if this one was system XY, then this one is system YZ. This one would be system XY. When I flip back, hit the space bar, and I can hit OK. So now it's clean, it looks nice, they're named the same thing. You're not having to do system XY-1, system XY-2, stuff like that. And then, so yeah, that was just a little fun tip there. I like to add those in that they're not groundbreaking, but sometimes, you know, teaching this to a customer, it's exactly what they've needed and frustrated them. So I always try to add these little just for fun tips into there. If you guys have any just for fun tips that you have realized that it's not groundbreaking, send them over. I'd love to have customer input content for these webinars. So feel free to send those over. So next thing I want to talk about is measuring flash or burrs. So I'm going to go ahead, I'm going to go back to my plan different mags. I'm going to run this program real quick just so I can find my part on my stage. See a couple questions coming in here. Dan, thanks for answering that there. And if there's anything that I mention in this webinar that you'd like to know more information about, shoot it in the chat box or send us an email and we can help you guys out with that. So, all right, measuring flash. What a joy. You know, we'd all wish that we have perfect molds and processes, that the flash is not causing us any problems here. So one of the more difficult ones is measuring flash on a radius surface here. Now this so much isn't flash, this is probably from the part being banged around, but it's a good example here. So down here, a very forgotten feature tool is the point cloud. Getting any raw data, measuring any lines or radiuses, anything like that, it's really nice to use a point cloud because you can pull data out of that point cloud and use it for multiple different things. In the program that I'll show here in a little bit, it was measuring this line down an edge, and they were looking for the most farthest point in negative X from the datum structure, and they were taking multiple just best edge points down the edge of it. But with the point cloud tool, so we'll go ahead and do this here. I'll come over to this line. With this point cloud tool, if I click point cloud and then I use the F-scan tool, it doesn't measure a line, but it's using the F-scan line tool to place points on the edge. And we can see over here in the schematic window that it's just raw data points, X, Y, and Z points that are placed on my part here. And if I click point, and then I click the point cloud, it's drawing an individual point out of all those points there. A lot of different options here that you can use. You can use maximum in X. You can use minimum in X. In this case, it's from my datum structure that I have set up on the corner of it. So I could see that individual point there when I click OK, gives me up here in my results summary window, it gives me the X, Y, and Z values from my datum structure. So going, it is 31.34 millimeters away in X, and that helps me out finding out if there's any, like what's, if the part is too large, too small, however it might be going. But using this for Flash is super helpful as well. Come back up to that little Flash that we have here. So here, if I do another point cloud, and then I do an F-scan arc, you notice that it kind of voids when you take an arc. Sometimes it's best fitting an arc through all those points, and sometimes it might avoid the actual flash there, but using a point cloud is more helpful because it just scans across that contrast on there. So now we can click point again. We can click that point cloud. And my datum structure really isn't the greatest for this area here, but you can see as we click through, you can see all the different areas here. Let's go ahead and find a better example here with my datum structure. So if I come up to this edge over here, let's get that in focus. So if I click and delete that point cloud, F-scan line, what I like to do is if my datum structure doesn't help me out finding the flash, instead of doing the point cloud, I'll do a line on that edge, and I'll set my origin and my skew to that line. So now my origin's over here, so it's right on that best fit line that we have. And then if I click point cloud, I don't have to remeasure that line. I can create a point cloud out of that line over here in the features list. And so now I originally had an F-scan line. I click point cloud, I click that F-scan line. So now it drew all those points out of that F-scan line. So now I can click point, I can click that point cloud, and I can see my max in X, and that's the direction that I'm going. You can find your minimum, which would be good for if you're dealing with any parting line mismatch. If you do a line across the parting line, and if it's the parting line doesn't match up, you're going to see a dip in that line. So the minimum on that in X or Y, whichever direction you're going, will show you that deviation. And then you can do a max of that. So let's go ahead and do that. So I'll do max first in X, and then I'll do another point out of that point cloud, and I'll do minimum. And now I have my 2 points, and I could do a line parallel to my original line through the point. So now I just created a line there, and then I'll do another line parallel to this line through the other point, and then you can do a gap between the two. And then I'm getting 0.06 of mismatch between my lowest point on that edge and my max point on that edge, and that would be your parting line mismatch on there. So the point clouds are real good to pull individual points out of that edge and get your flash, your burr measurements there. If this is something that you guys are having to report every day, burrs or flash that are allowed on there, like 10 thou, whatever it might be, and you guys are having difficulty on this, feel free to reach out to us. We're here for support. I can't say it enough. We're here to support you guys in your programming. All right, the next thing I want to talk about is measuring a chamfer. This is also flipping working planes. So I'm going to move over. I got this nice turned part over here that has a chamfer on it. Let's go ahead and find it. There we go. There's my part. So I'm going to go ahead and on this part, I'm going to do a line on the edge. I'm going to do this basically just to help myself find the center of this turned part. Let me go ahead and do a file new so my schematic window is not huge with all the different parts that I'm measuring. I'll come to the other side of the part, grab another F-scan line, and then I'm going to do a line, and I'm going to do a bisect line of those two, and that gives me the center of my part. I'm just going to go ahead and throw my origin and skew to that. I'm going to turn on my surface light. Now you can see, if you look in the schematic window, I occasionally forget to look at this. That gray square that's in the schematic window, that's where your camera's at. So if you're not sure where you're at on your part, you can look at your schematic window and look for that gray box, and that's where your camera is located on there. So if I come down other direction, so right here we got a nice little chamfer that we need to measure. Right here on the right side, it's a larger diameter. Chamfers down to a smaller diameter here, and we need to get the angle off of that guy. So one thing that you could do, which is the obvious, is you could come over to the side of your turn part and get it using profile light. But sometimes if it's a through or like a blind hole and you can't use profile light and it's looking straight up at you, we need to do some flip working planes to be able to get that chamfer there. Little lighting tip: any turn parts or round parts, use an axial light. You can notice that when I'm over the center of the part, the axial light is shooting straight down where the camera's looking, so you get less reflection on the part, and it also helps you out knowing exactly where the apex of that is in relation to your camera there. So I'm going to go ahead, I got my system. I'm going to rename this to being my system XY. And if you were in the January webinar, we talked about measuring radiuses, and we talked a little bit about measuring chamfers using flip working plane. It's something that is uncommonly used because it's pretty advanced programming. So I might hit flip working planes a lot for you guys to learn more about it and the cautions to take while flipping working planes. So remember, anything in Z, we're going to zoom in, get that in focus. Anytime that we're flipping working planes, I want to take raw points. I don't want to take these focus points along the edge to create a line. I want to just take individual points, because when we flip the working plane, we're going to use those raw points to construct lines of. Microview can do and handle 3D measurements, but one thing to think in the back of your head is that the software is thinking 2D first before it's thinking 3D. So when I take these points and I take a line and I'm just in XY, it's going to be mainly looking at the XY data. It's not going to be looking at the Z points when I try to construct these lines. And I'll show you two examples. So I'm going to take some focus points here, move on down, take one here. And then we want to get this chamfer. I probably could spend a little more time getting some better lighting for here, but for time's sake, I'm going to go ahead and just take these points here. And then let's go ahead and I'll go back to axial light for this surface down here. So I got my raw points here. If I click my front view, we can see that these points have Z value. Microview sees the Z values of these points. But if I'm in my working plane of XY and I click a line, more inputs, and I click these 3 points, you can see that it's almost averaging the Z data, but it's putting it straight in the XY, and it's not looking at the angle that it's seeing here. So I'm going to delete that. I'm going to click System, and I'm going to copy my System XY. So now down here we can see my System XY in my inputs list. And then I'm going to click Flip Working Plane, and it shows up YZ. It's kind of hard to explain over a webinar without looking at the machine, but if you're next to your microview, look at the front of the machine where it says microview and the model on the front. If you're looking in that direction, that is XZ. If you get on the side of your machine, that is YZ. One way to think about it is that if you're looking at the front of the machine, you can see the Z direction and you can see the X direction, but the Y direction is going away from you. And whatever's going away from you is not included in this right here. So if I click my PCS view, this helps me out seeing what the software is looking at the points that I took. And so since I'm in YZ, it's still seeing that they're kind of align with each other. So if I come down to the system and I click working plane again, it switches down to XZ here in my inputs. So if I hit PCS view again, now this is the way the software is looking at these points. And we can see those different points going down that chamfer there. So I'm going to rename this system XZ. Hit OK. And then now, since I took all my measurements in XY, it's always safer to take your measurements in XY, flip the working plane, and then use those points to construct your features. So now I'm going to click line. I can click and drag, highlight those. I got a line there. I'm going to click a new line. I'm going to click and drag around the points in my chamfer. And now we have that angled line that we're looking for. And then I'm going to do one more line up here with those. So now I got those, and now I can hit angle. And I can get whatever angle we're looking for. Got 45. Generally, you'll see a lot of 45s on your chamfers. Same up here. Whichever one you need to report on there that's being asked for. And then now I'll click System again, and I'll go up to my System XY. I'll copy it, and like the just for fun tip that we learned earlier, XY space, and hit OK. So now I hit PCS view, and now I'm back in my XY, and I can take some more measurements that I need to on this part there. So flip working planes, especially if you're using touch probe, can be a little bit dangerous. I want to say that it can be a little bit dangerous because when you flip the working plane, the software, you can think of it in a way of the software thinks the camera actually rotated, and that's the way that the machine's looking. So depending on how much you flip the working plane, you really can confuse the software which working plane you're in. So that's why I always go back to my system XY after I take my measurements, just so I know that I'm in that system. I'm good. I can take my measurements. I'm safe. Less risk of crashing the machine, and that kind of thing. So always go back to XY. So while we're on that topic, I want to thank the customer that shared this program. They allowed me to, let me go ahead and open it up to be able to show you guys this program that I helped them figure some things out. So I wanted to bring this up too. So the customer has a touch probe. Right now on my machine, I don't have these specific touch probes on my rack. So if you have a supplier or a customer that also has a microview, you guys can share programs. And if you guys don't have the same touch probe configuration, you can actually tell the software to use another probe that you own, and it'll be able to switch those programs to looking for that touch probe and using those specific styli to the ones that you have. Now, there's a lot of caution in there that if you have, this program was written with a 1mm ball. if you're trying to go into a feature with a 5mm ball, it should prompt you that it's not going to be able to work, but that's not always the case, and it might crash into the machine. So try getting as close to the same style eye and touch probe as the program that you have. And if you guys are needing to build your touch probe library, style eye are generally a cheap purchase there, so feel free to contact us and help build your stylus library to be able to measure more features. So I'm going to say use another one. I'm going to click I have this one, and I'll say next problem. I'm going to click same thing, and now I'm able to, so it just switched everything in that program to using this touch probe here, and I can click close. So here's the program, and as I rotate this part, you can see it's a pretty 3D feature that we have going on here. And this was actually the feature that I was talking about earlier, that instead of doing a bunch of points down an edge, if we're looking at the top here, doing a bunch of points down this edge, we did a bunch of point clouds, or we did one point cloud with multiple features in it. And we were able to use calculator function and using the point out of there to find the farthest point on that edge in -x on there. So a little trick that I showed you guys with the point cloud. So this feature here, the datum structure was a cylinder through the part, so we got our line there, and some planes that controlled our 6 degrees of freedom. But when we were looking at the blueprint, if I look at the side view here, they needed this plane distance from the origin. And the origin, if you did a distance from this plane to the original origin, we weren't getting the number because they weren't angled correctly together. So it was, instead of looking at the same angle, it was looking straight down, which created a larger distance between the two. So we needed to flip the working plane, so we were looking in this direction. Let me go down and find that system. So we had to flip to YZ so we can see those features, but then we also needed to rotate the system 15 degrees. If in this system, if I flip the working plane and I come over to offset, I can offset the angle of it. But when I offset this angle, it offsets it. Let me do it again, delete that for you guys so you guys can see. Let me zoom in here for you. So you can see the gray highlighted system there. If I rotate that, you guys notice that it didn't really rotate that 15 degrees. You can see this other system back here. That's not the one that rotated. I wanted to rotate that. What it actually rotated was still in XY. So if you're trying to flip a working plane and offset it at an angle, it only offsets it in XY, and then it'll flip the working plane. But I needed it to rotate in the YZ plane here. So a little trick that I learned was that I offset it. So now that I'm in my PCS view, I'm in the view I want, and then I copied the system and I clicked system 114 and it created this one, and then I was able to offset it that 15 degrees there. I want to say this with a lot of caution, that now the machine thinks that the camera is on the side of the machine and it's angled. So any touch probe or even vision measurements, taking it in this working plane can be very, very dangerous. So if you guys have prints like this that you need to require that really, really 3D modification of your systems, please bring us into the loop. Let us help you out with it. And as always, before you take any other measurements, you can see down here in my features list, I went back to system XY on there. So there's a lot of modification of the system that you can do to fit your print's needs, even if it's a really 3D print with really hard datum structures of 3D features. There are ways to do it. It just really got to think outside the box and how can we modify system to system on there. So as we're coming up to the 11 o'clock hour, I don't want to take too much of your time. I know we're all busy. So I want to open up in the just open forum, and you can put questions in the chat box. Any questions you have from today, or if you've seen anything that I've measured that's a good application for another question, I want to open up the time for you guys to do a little Q&A. I'll try to answer anything as possible in real time. If I am not able to do it in real time, Dan and myself will take down your name and we can contact you after and do a quick answering your question there. So if you guys have any questions today for me or Dan or anything about MicroView, feel free to pop them in there. It's always nice. The other participants can learn from your questions. And as hopefully somebody's typing in a question here, last thing that I just want to say is a reminder for that metrology training seminar. 3 days, you can register for 1, 2, or all 3 days. It's great for new techs that you want to get trained up on the MicroView. And the one thing that I love about these training seminars is you get multiple different companies from different industries, from medical to aerospace to plastics, and you all have different questions that you might not think about, and another company is asking them, and you get to learn more there. So send me an email if you're interested in there. It'd be great. And we're going to be hopefully doing more of these multi-day training seminars in cities closer to you. I know on this webinar we have everything from Nebraska to Indiana to Ohio to Missouri, and even some Texas MicroView programmers today. So hopefully we can bring this training seminar to a region closer to you. So yeah, I don't see any questions popping up in the chat box here, but we'll stay on here for a little while longer. If you have any questions, feel free to pop them in there. If not, thank you all for attending this webinar. And in the future, if you're not able to make it day of, please still register so you can get the recording of it after it's done, and just to help you and your team out there. So thank you very much. Hope you all learned at least a little something today, and we will talk to you soon.